is by David Leslie from the Turing Institute, who's going to be talking about from principles to practice and back again, building a responsible AI ecosystem from the ground up. Thank you.
Thank you so much. And we're just really glad to be here. I hope everybody's having a good conference so far. Yeah, so I wanted to talk a bit today about what we might think of as the conditions of possibility for operationalizing ethics and governance in data science and AI research and innovation ecosystems. So taking the term responsible data science or responsible AI in its most concrete boots on the ground sense, I'll do this by peering through a kind of practice-based lens that focuses on socio-technical AI project life cycles. In this way, it makes sense to begin by sort of fleshing out what has become quite familiar to those of us steeped in conversations around responsible AI as the move from principles to practice. Now, the recent history of AI ethics and governance has been characterized by increasingly vocal calls for a shift from principles to practice. Over the past several years, some have discerned a rapid transition in the field from an initial concentration on high-level principles and techno-solutionist fixes towards a third wave of hard-nosed advocacy and legal action that is focused on practical mechanisms for rectifying power imbalances and achieving individual and societal justice. Others have emphasized that closing the gap between principles and practice should involve the employment of myriad tools and methods throughout the various stages of an AI project or data science project lifecycle, so that the what of ethical principles can be translated into the how of technical mechanisms. Others still have called for a strengthening of regimes of auditability, traceability, reviewability, and other terms, emphasizing the importance of oversight, accountability, and transparency as the key to the effective governance of responsible AI research and innovation. Now, while it must be acknowledged that this intensifying concentration on the nexus between moral concepts or principles and social practice has substantial merits, it is also important to point out that these perspectives have fallen short of fully realizing the transformations they identify and enjoin. Those who have turned to the incorporation of a patchwork of technical tools and documentation methods into the various stages of the AI and data science project lifecycle have provided an important bird's eye view of recording, auditing, and standards conformity desiderata. They have focused, for instance, on how to document the creation, composition, and intended uses, maintenance, and other properties of data sets, thinking here of Gebru et al.'s now pretty well-known proposal for data sheets for data sets. Or they have focused on how to encourage transparent model reporting through documentation detailing their performance characteristics, as with the promotion of model cards by Meg Mitchell et al., which was a paper published in 2019. Now, such documentation-centered governance strategies, however, have run the risk of remaining too far above and outside of the actual socio-technical processes behind the innovation practices they endeavor to document. The problem here is not that the tools and methods like data sheets, data nutrition labels, data statements, model cards, and fact sheets are of no use as provisional attempts at closing the gap between principles and practice, but rather that the aerial view that they take is liable to neglect the social, cultural, and cognitive preconditions of the responsible innovation practices they aspire to advance. Cobbling together a robust toolbox of mechanisms to support the verification of claims about AI systems and development processes in this latter sense leads in AI ethics and governance to a kind of functional tardiness of the governance strategies that results. Namely, it leads to an emphasis on narrowly targeted methods such as effective assessment, auditability, traceability, and reviewability that show up on the scene a moment too late. Such methods remain ex post facto and external to the inner workings of sufficiently reflective and responsible modes of technology production and use. It is at this latter, more foundational level of cultural formation, value shaping, and action orientation that a bridging of the gulf between principles and practice in AI ethics and governance and data science ethics and governance must begin. So beyond off-the-shelf tools and documentation-centered governance instrument, closing the gap between principles and practice requires a transformation of organizational cultures, technical approaches, and individual attitudes from inside the processes and practices of design, development, and deployment themselves. Achieving this requires researchers, technologists, and innovators to establish and maintain end-to-end habits of critical reflection and deliberation across every stage of the research or innovation project lifecycle. This more basic organizational, technical, and even psychological transformation entails that designers and developers of data-driven technologies pay deliberate and continuous attention to the role that values play in both discovery and engineering processes, as well as in considerations of the real-world effects that these processes yield. It requires sustained interdisciplinary efforts to consider the multifaceted context of research and innovation, to anticipate potential impacts, to reflect on purposes, positionality, and power, and to engage affected stakeholders inclusively in order to ensure appropriate forms of social license and democratic governance. An approach to building trustworthy AI systems and data science models that takes as its starting point a focus on technologically based tools or documentation protocols, like the ones I've just mentioned, erroneously works from the outside in. All the while, the actual change that is required to bridge the divide between principles and practice must instead originate from within actual research and innovation activities as part of a deeper transformation of the organizational environments and individual attitudes, standpoints, and dispositions, whence those activities themselves derive. So the first and most crucial inroad to this practice-driven and process-based approach is a reconceptualization of the innovation and research workflow as a socio-technical life cycle. Okay, so I want to talk a little bit about what that term means. What is a socio-technical life cycle? Well, as a start, it means that we have to understand the development of AI technologies and data-intensive models to be the result of a complex set of interrelated processes. As a general heuristic, these processes can be broken down into stages of project design, model development, and system deployment, each having a subset of activities. For instance, project design will include actions like project planning, problem formulation, and data extraction and procurement. While there are many ways to carve up the project lifecycle, such as build management, deploy, and integrate monitor scheme of ML ops, or the KDD, CRISP-VM, or SEMA workflows, it's important to keep in mind that all framings of the project lifecycle must remain flexible and responsive to the dynamic and iterative character of data science research environments and also AI innovation practices. However, even more importantly for our reconceptualization of the workflow, we need to think about these project stages and activities not simply as techno-scientific or research processes that are operationally independent from or even immune from the conditioning dynamics of the social environments in which they are embedded. We need additionally to think of these same processes as fundamentally social processes, and we need to regard the activities which steer these processes as ethically implicated social practices that are duly charged with a responsibility for critical self-reflection about the role that human purposes, values, and interests play, both at every juncture of the discovery, engineering, and design process, and in considerations of the real world effects of the insights and technologies that these processes yield in the real world. From this, what we might call, or what's been called, the science with and for society perspective, we can begin to discern that from the earliest stages of the socio-technical project lifecycle, human choices and values are integrated into data science project design, model development, and system deployment. At the project planning stage, for instance, human judgments need to be made about whether building an algorithmic model is the right approach given available resources and data, given existing technologies and processes already in place, given the complexity of the use contexts involved, and given the nature of the policy or social problem that needs to be interrogated or solved. These path-determining choices wield an overriding agenda-setting power in AI innovation and data science ecosystems, a power that is all too often hoarded by those that control resources and that is thus exercised in ways that are at cross purposes with normative goals of democratic governance and public consent. At the problem formulation stage as well, human evaluations and interests also shape the determination of what problem an AI technology or data science project is trying to solve, and what target variables should be implemented within a given system. This means that the very acts of devising the statistical problem and of translating goals into measurable statistical proxies can introduce structural biases, which may ultimately lead to discriminatory harm. Likewise, at the data preprocessing and feature engineering stage, human decisions about how to group or disaggregate input features, for example, how to carve up categories of gender or of ethnic groups, or about which input features to exclude altogether, for example, leaving out deprivation indicators in a predictive model for clinical diagnostics. All of this can have significant downstream influences on the fairness and equity of a given project system. These socio-technical pain points direct us towards an end-to-end incorporation of habits of responsible research and innovation into all of the research and innovation activities in which we engage. An RRI perspective provides researchers and innovators with an awareness that all processes of scientific discovery and problem solving possess socio-technical aspects and ethical stakes. I'll talk now a little bit then about what's called the Karen Act framework. It's a tool of responsible research and innovation. This is an acronym for consider context, anticipate impacts, reflect on purposes, positionality, and power, engage inclusively, and act responsibly and transparently. This framework aims to be a handy tool that enables researchers and technologists to continuously sense check the social and ethical implications of their research practices, and that helps them to establish and sustain responsible habits of scientific investigation and reporting. So let me take each of those letters in turn. First, consider context. Think diligently about the conditions and circumstances surrounding AI and data science projects and their outputs. This involves focusing on the norms, values, and interests that inform the people undertaking the research and innovation, and that shape and motivate the reasonable expectations of those who are likely to be impacted by the research and its results. All in all, contextual considerations should at minimum track three vectors. The first involves considering the contextual determinants of the condition of the production of the research and innovation. For example, thinking about the positionality of the project team, the expectations of the relevant data science or AI community of a practice, and the external influences on the aims and means of research innovation by funders, collaborators, and providers of data and research and innovation infrastructure. The second involves considering the context of the subjects of research and innovation. For example, if we were extracting or scraping online digital traces, we would need to think about observed data subjects' reasonable expectations of gainful obscurity and privacy in public, and consider the changing context of their communications, such as with whom they are interacting, where, how, and what kinds of data are being shared. The third track involves considering the context of the social, cultural, legal, economic, and political environments in which different research and innovation projects are embedded, as well as the historical, geographic, sectoral, and jurisdictional specificities that configure such environments. For example, thinking about the ways that different social groups, both within and between cultures, understand and define key values, variables, and studied or operationalized concepts, perhaps differently, as well as the ways that these divergent understandings place limitations on what the computational approaches to prediction, classification, or modeling can actually achieve in reality. So this is an idea that we need to think in the context of impacted communities, thinking thinking circumstantially about those contexts so that we can align our vision, our research and innovation with those visions of those we are impacting. So the second following from this is anticipate impacts. Basically reflect on and assess the potential short-term and long-term effects that AI and data science innovation projects may have on impacted individuals and on affected communities and social groups more broadly. The purpose of this kind of anticipatory reflection is to safeguard the sustainability of data science and AI projects across the entire workflow or life cycle, to ensure that the activities and outputs of research and innovation remain socially and environmentally sustainable, and support the sustainability of the communities and individuals they affect. Researchers and technologists must proceed with a continuous responsiveness to the potential real-world impacts of the research that they engage in. This entails concerted and stakeholder-involving exploration of the possible adverse and beneficial effects that could otherwise remain hidden from view if deliberate and structured processes for anticipating downstream impacts were not in place. Attending to sustainability along these lines also entails the iterative revisitation and reevaluation of your research or innovation impact assessments. To be sure, in its general usage, the word sustainability refers to the maintenance of and care for an object or endeavor over time. In the AI and data science context, this implies that building sustainability into a research project is not a one-off affair. Rather, carrying out an initial research or stakeholder impact assessment at the inception of a project is only a first, albeit a critical step in a much longer end-to-end process of responsive reevaluation and reassessment. Such an iterative approach enables sustainability-aware researchers and technologists to pay continuous attention both to the dynamic and changing character of the research lifecycle and to the shifting conditions of the real-world environments in which studies and systems are embedded. Think here simply about distributional drifts or shifts that can cause a system or a model to be less effective over time. So third part of the CARE and ACT framework, the R, reflect on purposes, positionality, and power. Engage in reflexive practices that scrutinize the way potential perspectival limitations and power imbalances can exercise influence on the equity and the integrity of a data science or AI research and innovation project, and on the motivations, interests, and aims that steer those projects. The imperative of reflecting on purposes, positionality, and power makes explicit the importance of a kind of dimension of inward-facing reflection. All human beings, more specifically, come from unique places, experiences, and life contexts that shape their perspectives, their motivations, and their purposes. Reflecting on these contextual attributes is important insofar as it can help researchers and project teams understand how their own viewpoints might differ from those around them, and more importantly, from those who have diverging cultural or socioeconomic backgrounds and life experiences. Identifying and probing these differences enables individual researchers or innovators to better understand how their own backgrounds, for better or worse, frame the way they see others, the way they approach and solve problems, and the way they carry out research and engage in innovation. By undertaking such efforts to recognize social position and differential privilege, they can begin to gain a greater awareness of their own personal biases and unconscious assumptions. This then can enable them to better discern the origins of these biases and assumptions and to confront and challenge them in turn. Now, social scientists, which is my background, have long referred to this site of self-locating reflection as positionality. When researchers take their own positionalities into account and make this explicit, they can better grasp how the influence of their respective social and cultural positions potentially creates research strengths and limitations. On the one hand, one's positionality with respect to characteristics like ethnicity, race, age, gender, socioeconomic status, education, and training level, values, geographic background, etc. All of these elements of positionality can have a positive effect on an individual's contribution to a research project. The uniqueness of each person's lived experience and standpoint can play a constructive role in introducing insights and understandings that other team members on a research team or a project team don't have. On the other hand, one's positionality can assume a harmful role when hidden biases and prejudices that derive from a person's background and from differential privileges and power imbalances creep into decision-making processes undetected and subconsciously sway the purposes, trajectories, and approaches of research projects and ultimately have adverse downstream impacts. A solid grasp on positionality allows researchers to better interrogate and reflect on the power dynamics that could unduly influence research purposes and trajectories. Such reflections on power should involve an investigation of how power operates and where it manifests, both across the research and innovation lifecycle and in the real-world environments in which research and innovation practices, results, and outputs are situated. This involves making potentially noxious power dynamics explicit by posing questions like, what if any power imbalances exist between me or my project team and the communities impacted by our innovation activities? Do the research and innovation agendas I currently pursue reinforce or challenge these imbalances? How, if at all, do these imbalances result in unjust exercises of power? Are my current activities entrenching or combating such exercises of power? Fourth and final letter E, engage inclusively. So what does this involve? Undertake practices of meaningful outward-facing stakeholder engagement and community involvement so that the views and values of the individuals and communities impacted by data science and innovation, AI innovation projects can help shape them. While practices of inward-facing reflection on purposes, positionality, and power can strengthen reflexivity, objectivity, and reasonableness of research and innovation activities, practices of outward-facing stakeholder engagement and community involvement, even participatory co-design, can bolster a research project's legitimacy, social license, and democratic governance, as well as ensure that its outputs possess an appropriate degree of transparency. A diligent stakeholder engagement process can help researchers to identify stakeholder salience, undertake team positionality reflection, and facilitate proportionate community involvement and input throughout the research or innovation project workflow. This process can also safeguard the equity and contextual accuracy of impact assessments and facilitate appropriate end-to-end processes of transparent project governance by supporting their iterative revisitation and reevaluation. Moreover, community-involving engagement processes can empower the public and the innovation community alike by introducing the transformative agency of citizen science and participatory co-design into research and innovation processes. Now, finally, no letters any longer, so we have care, now act. Act transparently and responsibly. Marshal the habits of responsible research and innovation cultivated in these care processes to produce research and innovation that prioritizes data stewardship and that is robust, reliable, secure, sustainable, fair, non-discriminatory, and explainable. While the mechanisms and procedures which are put into place to ensure that these normative goals are achieved will differ, obviously, from project to project based on specific research contexts, research design, and research methods, all data science and AI researchers should incorporate certain priorities into their governance and self-assessment and reporting practices. I'll just give you four as examples. First, full documentation of data provenance, lineage, linkage, and sourcing. This involves keeping track of and documenting both responsible data management practices across the entire research lifecycle, from data extraction and procurement and data analysis, cleaning, and pre-processing to data use, retention, deletion, and updating. It also involves demonstrating that the data are ethically sourced, responsibly linked, and legally available where appropriate for research purposes, and making explicit the measures taken to ensure data quality, data integrity, and fair data, findable, accessible, interoperable, and reusable data. Two, full documentation of privacy, confidentiality, consent, and data protection due diligence. This involves demonstrating that data has been handled securely and responsibly from beginning to end of the research lifecycle, so that any potential breaches of confidentiality, privacy, and anonymity have been prevented, and any risks of re-identification through things like triangulation and data linkage have been mitigated. Regardless of the jurisdictions of data collection and use, researchers and innovators should aim to optimally protect the rights and interests of research subjects by adhering to the highest standards of privacy preservation, data protection, and responsible data handling and storage. So thinking of here, FAIR principles, the GDPR, the other data stewardship mechanisms, for instance, the 5 safes in the UK example. Third elements of acting responsibly: transparent and accountable recording of research and innovation processes. So R&I processes and methodological conduct should be carried out deliberately, transparently, and in accordance with recording protocols that enable interpretability, reproducibility, and replicability of results. Obviously, this is a normative principle, and as I'm sure that's the first session has already established, issues of interpretability, reproducibility, and replicability are part of I think an open conversation, the one that we really need to keep alive, especially with the processing of social and demographic data, where we really do need to secure transparency. The final element of ACT is an end-to-end process for bias self-assessment. So bias self-assessment should cover all research stages, as well as sources of bias that could arise in the data, in data collection, in the pre-processing, in the organizing, categorizing, describing, or annotating, or structuring the data, and in research design and execution choices. An end-to-end process for bias self-assessment should move across the research lifecycle, pinpointing specific forms of social, statistical, and cognitive bias that could arise at each stage. For instance, social biases like representation bias and label bias, as well as statistical biases like missing data bias and measurement bias, could arise in the data pre-processing stage of a research project. Now, to close, and with all this said, let me make one final general observation. And this is really, I think, more of a forward-looking or kind of positive spin on what is, I think, a set of difficult tasks that lie ahead. As quintessential social impact sciences, AI and data science holds great promise to advance social justice, human flourishing, and biospheric sustainability. However, data science and AI are also all too human sciences, conceived in particular social, cultural, and historical contexts, and pursued amidst intractable power imbalances, structural inequities, and potential conflicts of interest. Their proponents in both research and innovation communities must thus remain continuously self-critical about the role, as I mentioned before, that values, interests, and power dynamics play in shaping mission-driven research. Likewise, they must vigilantly take heed of the complicated social and historical conditions surrounding the generation and construction of data, as well as the way that the activities and theories of data science and AI researchers can actually function in the world to reformat, reorganize, and reshape the phenomena they purport only to measure and to analyze. Such a continuous labor of exposing and redressing the often concealed interdependencies that exist between AI and data science and the social environments in which their activities, subject matters, and outputs are embedded will only strengthen their objectivity and ensure that their impacts are equitable, ethical, and responsible. Such a human-centered approach, I would argue, will make data science and AI sciences with and for society that are second to none.